Okay, so 3.4. Derivative is rate of change. So in algebra, we said the rate of change is slope because it's a change in y or change in x, right? Okay. We're gonna do some formula for today. So here, let me just skip the average rate of change because we know there is a slope of secant line, right? Now we have instantaneous rate of change. Continuous rate of change. So f prime of a equal to of, then let me write down, of the function at a, right? So we have a there. Then limit h approach to 0, f of a plus h minus f of a over h, right? So h approach to 0 means we don't get into 0, right? Look, denominator, we cannot have 0, right? Because undefined, right? So make it close to the 0, right? And that means it can be 0.00000000000 stop me 0.0001 like that, right? Very tiny number, right? So we say that this is small enough, right? Values of h, right? Okay, then we can take out now. H approach to 0 means we make a small enough values of h. So let's say that 4 small enough values of h. Then we can take out the limit h approach to 0. So we have f prime of a equal to f of a plus h minus f of a over h. Now solve for f of a plus h, okay? Then we times h. So we get let me write down this way. Right? Then we add f of a both sides. So we can express this one. And we make approximately. So this will be f of a and plus f prime of a h. All right. So this one we're gonna use for estimate. Estimate the value of f of a plus h. All right. Now this one, they indicate that when do we are using for population growing, those kind of application. So let us do that first. Then we do motion along line. All right. So Let me go over next page. Let me erase. On the top. Because we need a formula. Okay. All right, so example. The population of a city tripling every 5 years if its current population is 10,000. What will be its approximate population 2 years from now? Okay, so here, let us make it short in thousands. So let P/T be population. So we are using P, the first letter from population. Okay, so no meaning at all. P population. Hold on. In thousand. Thank you. It's, yeah, in the thousand. Thousand. And then T years from now. Okay. We're gonna set it up P of 0. So what do you get? P of 0 is now, right? What do you have?
10,000.
Good. But then we're using just the 10 because of thousands there. Okay. Now, how about P over 5?
$30.
Excellent. 30. Okay. Now, let us estimate P of P prime of 0. So P prime of 0 approximately. So P of 5 minus P of 0 over 5 minus 0. So P over 5, which is 30, minus 10, P over 0, which is 5. Can you please calculate this one?
4.
4, excellent. Okay. Now, we're gonna use this formula, okay? Since they ask us 2 years from now, so P of 2 days, 2 years. Approximately P of 0 plus P prime of 0 and times T. We're gonna do that. So that is 2. So we're gonna get P of 0, which is 10, plus P prime of 0, which is 4, and times T, which is 2. Can you please calculate this one?
28.
28. Thank you. 28? 18. Thank you. So let us conclude. This means in 2 years, the population will be 18. We're missing 1,000 there, right? So 1,000. All right, in this case. All right, so let me do homework problem like a mosquito. All right. Let me erase this one. Let me erase the top because I needed the formula. I think this is from your homework, like a last question. So the current population of the mosquito colony is known to be 585. That is P of 0 equal to 585. If P prime of 0 equal to 84, estimate the size of the population in 9 days, where T is measured in days. Okay, so we don't have to find the growth rate like P prime of 0, right? It's given. So then we have a formula in the bottom. So let us make P of 9 days in this case. Approximately, we do P of 0 plus P prime of 0 times T. Okay, so what do you get? P of 0, what do you have?
585.
585 plus P prime of 0.
84.
Thank you. And T?
9.
9. Can you please calculate? Let me erase this one.
585 plus 756. Total together 1,341.
Thank you very much. Okay, so mosquitoes. Mosquitoes. Easy to apply, right? Okay. All right. Now, let us do motion. Let me erase. So we often write down S of t like a position function. Of an object at time t, the velocity of the object at time t is given by v of t equal to s prime of t, which is first derivative. Now speed of the object. Let me make a detour. And by speed, we need just numbers. So the absolute value of the v of t, which is the velocity. Okay. Now the acceleration of the object detour by, look, the acceleration we denote a of t. Just they're using first letter from acceleration a and velocity first letter v, right? Then this is the same as how they find the acceleration, which is v prime of t from the velocity first prime, okay? The derivative of velocity, in other words, okay? Then this is the second prime of s of t, which is the second derivative from the position function, right? So we do that. All right. Let us do this example. A ball is dropped. From a height of 64 feet its height above ground in feet, t seconds later, given by S of t equal to negative 16 t squared plus 64, okay? Now, number one, first one, what is the instantaneous velocity of the ball when it hits ground? Okay. So first of all, we gotta find the t first. Okay. So let us make the position function s over t, set it up equal to 0 because ground, right? So then find the t. Then we find the velocity, instantaneous velocity. When t, okay, t equal to that number, all right? So here, let's say that negative 16 t squared plus 64 equal to 0, and solve for t first. Okay. Then how do you solve for t?
Subtract 64.
Yeah, 64. So we have negative 16t squared equal to 64. And
Divide by
t, yeah, t squared is, can you please calculate this one? What do you get?
-4.
Negative 4?
I think the sign is wrong.
Yeah, sign is not right. What's going on?
It's negative 64.
Should be negative 64, right? Yeah, I think Boom made a mistake. I have a hard copy. But the graph is negative 64. No, wait. We made a mistake. Not Boom made a mistake. We made a mistake. It's we subtract, right? Sorry. Thank you. Good thing. So t equal to 4, okay? Yeah. Sorry, book. I blame you.
we take the square root of 4, right, to get 2?
Thank you. So we get t equal to only positive part because time, right? So we get the 2. Good. Now, all right. So we find instantaneous velocity, which is s prime of t. Okay. So what do you get? What do you have? This one?
Negative 32.
T, right? Then, which is velocity over t. Now, we're gonna plug in, substitute, hit the ground when t equal to 2, right? So we want to know about the instantaneous velocity at t equal to 2. So negative 32 times 2, what do you get? Negative 64. Why you get the negative 64? What does that mean? Per second in this case. Yeah, t is the second. What does that mean? T equal to, I mean the negative 64.
Is it falling
It's
down?
flowing.
Going down, good. Yeah, like that, right? Because you're up the wall. All right, then can I erase on the top and then we do second part? So second part is average velocity. Okay. Let me erase the top. So let me write down the problem first. The what is the not the what is what is the average velocity? Do you remember how do you find this one?
Absolute value of v of t.
This is speed.
What was that?
That's the speed. Absolute value of velocity is the speed.
Oh,
Okay, so
Prime of t. Is it S prime of t?
we did S prime of t, which is the first derivative as the instantaneous velocity, right?
I think it's the secant line maybe, which is just normal slope.
Secant line, slope of secant line. So we did a lot of problems in the homework, right? In 2.1, right? Yeah. Thank you. So this means slope of secant line. So we denote this way. Then we're gonna find S of 2 minus S of 0. Drop the ball from the t equal to 0 until hit the ground, t equal to 2, right? And 2 minus 0. S of 2, what do you get? S of 2?
0.
0, thank you. How about S of 0? S of 0, easily to see.
64, 64.
64 minus 2. So what do you have? Negative 64 over 2.
Wait, is it
Negative 32.
Negative 32. Feet per second, right? Okay. So this is
Oh wait,
average.
yeah. Is it supposed to be 0 plus 64 since S of 0
No,
is
this is
negative
average
64?
velocity. Average velocity and slope of secant line.
Yeah, but S of 0 is negative 64.
S of 0 is positive 64, right?
Oh, okay, yeah.
And we have a subtraction there.
Okay.
Okay. All right. Let me erase this one. Okay. All right. Interpreting. The relation should this is title, subtitle there, so I don't need to write down this one. I'm gonna just write down the example. A particle moves along a coordinate axis in the positive direction to the right. Its position at time t is given by s of t equal to t cube minus 4t plus 2. Find v of 1, which is a velocity at t equal to 1, right? And a over 1, which is acceleration at t equal to 1. And use these values to answer the following questions. A. Okay, let us find b over 1 is 8 over 1 first, then we start A, okay? Velocity, which is s prime over t, right? What do you get? You guys are busy with the writing.
I got 3t squared minus 4.
Excellent. Then how do we indicate velocity at t equal to 1? What's that? What do you get?
-1.
-1, okay? And how about we want to about the acceleration? That is the v prime of t, that is the second prime of s of t. So what do you have?
6t.
6t, good. Now we want to find what's the acceleration when t equal to 1. So 6 times 1, what do you have?
6.
6.
6, good, thank you. So we got that. Now, first one is the particle moving from left to right. Right. Or from right to left. When t equal to the time t equal to 1. Okay, so we're gonna check the velocity at this time. Okay, so we have when t equal to 1, what do you have? Velocity? it's -1, right? So it's -1 means less than 0. So we can say that this is particle is moving from right to the left. If we have a positive, then we can say that from left to the right, all right? So let me show you the path later on. Let me see. Let's see. Moving from right to left. Okay, then second part is the particle speeding up or slowing down. At time t. Okay. All right. So we have velocity at t equal to 1. Let me just denote because we know v of t, right? And it's a -1, which is less than 0. And acceleration, when t equal to 1, we get 6, which is positive. It's greater than 0. Okay. So we have opposite direction. Okay, so in opposite direction, one is opposite direction means speeding down, slow down, okay? Slowing down. So if we analyzing speeding up or slowing down, then we have to have a same sign. Okay, so must be same sign means also negative for the velocity, also acceleration, also positive for the velocity or acceleration for positive. So same sign, okay? Then speed up, okay? Slow it down means the opposite sign, make it slow down, okay? Let me show you a path later on, why two negative sign is also speeding up, okay? All right, let us do position and velocity here. Let me erase, and then I'm gonna write down the word which I just said up in statement here, okay? Let me write down, since we have time. Interpreting the sign of acceleration. A particle in motion is speeding up when its velocity and acceleration have the same sign. And slowing down when they have opposite sign. So opposite sign. So think, okay? So think opposite sign means opposite direction. So they against each other, right? So that's why slowing down. And same sign means goes the same direction. That's why speeding up, okay? All right, let's do this one, then one marginal cost. Then we are done. But we have 3 questions here. Okay, let me erase this one because I need a space for this problem, okay? You guys busy with the writing, huh? Okay, let me erase. Let me just write down. So particle moving along a coordinate axis is given by S of t cubed minus 9t squared plus 24t plus 4, and t is greater or equal to 0. The first one, find velocity. Second one, at what times is a particle at rest? And third one, on what time intervals is the particle moving from left to right? And number 4, right to left. Number 4, we're gonna just draw the path from the book, okay? So first one, what's the v over t velocity? That is s prime over t. What do you get? Hello, why don't you take a picture later on? You guys are busy with the writing. Answer. Answer this one.
3t squared minus 18t plus 24.
Excellent. Okay. Second one, the what time is the particle rest? So we're gonna make a set equal to 0, right? So v of t equal to 0, which is 3t squared. Oh, thank you. Minus 18t plus 24 equal to 0. Can you please factor out this one? Okay, we can factor out with the 3, right? Then can you please factor out?
Wait, you can factor out. Oh, yeah.
Yeah.
I thought you said you can't. Sorry. 3 t squared minus 6t plus 8
Oh, sorry.
plus 8. and then you can t minus 6, and then t minus t minus 4, t minus 2.
Excellent. So which is t minus 4 equal to 0, or t minus 2 equal to 0, t equal to 4, or t equal to 2, right? Okay, now C part. Let us using sign analysis. When t equal to 2 and 4, and this is t, all right? Then we're gonna start to 0, right? Make sense? So start to 0, and then we have a 2 there, 4 there. Then particle is rest at this time, so we make a dot. Okay. Now, we're gonna analyze v of t. So just plug in t equal to between 0 and 2. What do you want to pick? What number would you like to pick?
1.
1. So plug in 1 there. So what do you get? Is it positive or negative? 1. 1. So 1. So negative. Oh, we need 24. So what can you calculate? Or we can just using t minus 4, right? So 1. So it's negative, and 1. It's negative, it's a positive, right? 2 negative is positive. I'm using the very last one, t minus 4, t minus 2, right? Okay. You guys are okay? Is okay? Now, between 2 to 4, what do you want to use? Two to 4?
Between 2 and 4? 3?
3. So v over 3. I'm using t minus 4, t minus 2, so 3. 3 minus 4 is negative. 3 minus 2 is positive, is negative, right? Okay. Now, after 4, what would you like to use? What do you want to use?
7.
7? Okay, lucky 7. V over 7. So 7 minus 4 is positive. 7 minus 2 is positive. So it's positive, right? All right. So in this case, positive means from left to the right. Negative means from right to the left. All right. Okay, so what's the question? What time intervals is the particle moving from left? Oh, we have to answer both, right? So from left to the right. So let me write down from left to right. Then left to the right. We are looking at the plus sign. So it will be 0 to 2. And they're using not union, huh? Union. So union of the positive part, which is 4 to infinity. Okay. Now from right to left, there is just an interval there, negative sign, which is 2 to 4. Okay. And let us make a path. It's really fun. So let me just using from the book. So this will be, yeah, it's the rest, right? They said it rest there. So when hit the 2 and 4, and then also t equal to 0 is a rest, right? All right. So we start to 4 because t equal to 0, right? T equal to 0. Where is the s of t? S of t. S of t, looking at the s of t. When t equal to 0, we get 4, right? Then that. Then they go to this way, right? Then 24. 24. So that is when t equal to 2. Okay. Now they change the path like this. Oops. And like that. It's in this case, let me write down here. T equal to 4 is 20. Okay. Then go to path like this. Okay. That is left to the right. Okay. I should not write down this one. You might get confused because error. Sorry. So this is t equal to 4. And then, oh my goodness. I messed up. Like this, okay? This is the t equal to 4. I was not. Okay. Wow, it takes a lot of time to draw this. Why I'm doing this one? Sorry, oh my goodness. Erase all the time. Try to make a really nice picture, then erase all the time. Yeah. Okay, no more. Okay, let's move on.
Wait, what
Yeah.
is the graph? What is the line representing?
This is a path, particle. We are
Oh,
using.
the path of particle. Okay. Okay.
So this line actually the position, and then the particle is moving through the velocity. Okay, the path. So this line is the position, the bottom line. Okay, and then they're using the velocity here. All right. Okay, so let us do the last problem here. Okay, last formula is here. The name of the formula is a little bit confused. So let me write down C producing X items, then the marginal cost. So they using marginal cost is MC. Okay, so just the first letter from M, marginal, and then second letter, the cost, right? The first letter from the cost, so MC of X. There's no meaning, okay? So MC of X, which is C prime of X, okay? So which is C is the cost of producing X items, all right? Now we have R of X is the revenue obtained from selling X items. Then marginal. It's so hard to pronounce. Marginal revenue. MRX, right? So they're just using first letter. There is no meaning. Equal to R prime of X. Okay. One more. P of X equal to R of X. So R of X means we just did the revenue. Okay. And C of X is cost of producing X items. Then it's the profit obtained from selling X items. Then the marginal profit. So they're using MP, first letter from the vocabulary is defined to be, look, see, I told you a little bit confused, right? I will just write down. Your homework just ask you about this one. Very straightforward, okay? Let me write down. How about that number of barbecue dinners that can be sold next can be charged related to the price charged. P by equation P over X equal to 9 minus 0.03X. Let me change this question like a homework question, okay? And then R of X equal to, they mentioned that like this. For X is between 0 and 300. Okay, so find the marginal revenue. How about that? Okay, I just changed the problem right now because I don't have time to go over everything. All right, let me erase on the top. So can you please just find out R prime of X? I should give it to you. One. Okay. Let me erase. So what is R prime of X? So marginal revenue, which is R prime of X. So R prime of X equal to what? Can you please give it to me?
Is negative 0.06x plus 9.
Okay, say it one more time. Negative
0.06x plus 9.
Thank you so much. Then when X equal to 101, oh, then we get the negative. All right, so negative 0.0 and then 101 plus 9. What do you get?
Um, 2.94.
Oh, 2.94, good. $2.94. Okay. So I just made up. So it's a little bit different with the book, but this is a homework problem. Okay. So your homework asks you about this one, marginal revenue. Okay, let me erase this one. Okay.